Okay, kids, now it's time to do all the examples for section 11.1, Intro to Logarithms. So we're continuing with that section, so we'll do some examples. So little a, let's try number 6 out of the textbook. Okay, number 6 says to rewrite the equation using exponents instead of logarithms. All right, well, number 6, we're given log of 1 over 10 cubed equals negative 3. All right, well, here you just use that log statement that I gave you earlier in the previous lecture. The left-hand side says, what do I raise 10 by to get 1 over 10 cubed? And the answer to that question is negative 3. So we read this as negative 3 is the power I raised 10 by to get 1 over 10 cubed, and we just write it that way. So 10 is the negative 3 is the power that I raised 10 by to get 1 over 10 cubed. And that is exactly how you rewrite logarithms into an exponential equation. So let me write that in words. Negative 3 is the power we raise 10 by to get 1 over 10 cubed. And we just put that in a mathematical equation, and it's just like that. So that's how you do those. So now let's look at number 18. So number 18, here we're going to solve some equations. So let's solve, let's see, where is it? 10 to the x equals 421. 10 to the x equals 421. Well, the whole idea here is, first thing we want to do is we want to solve for the exponential piece. Well, that's already done, so we want 10 to the x equals in this section. So since that's done, now what we want to do is apply the common logarithm to each side. Alright, so when we do that, we get log of 10 to the x equals log of 421. Okay, and then from the properties that we learned in the last video, the log of 10 to the x is simply x, and we're left with log of 421 on the right. And what we do is we now take our calculator, okay, take our calculator, and we press log. Log is the button next to 7 of 421, and press enter. And that gives us our approximation, 2.62428, so we'll round that to 4 decimal places. So we get x is approximately 2.6243. Okay? So that's how we do those. Not too difficult at all. All right, let's try another one. Little c. Let's look at number 24. Let's solve this equation. 15.5 equals 10 to the y. Okay, well, we do the same thing we just did. We want the 10 to the y to be by itself on one side, so we have that. So now we just apply log to each side. So we get log of 15.5 equals log of 10 to the y. Well, on the right here, log of 10 to the y is simply y. And then we plug log of 15.5 in our calculator. Well, I'll write it down first, log of 15.5. So the exact answer is log of 15.5. But we plug it in our calculator to get 1.1903. So 1.1903 equals y. And that's it. Okay? So let's go on to some different ones. Now let's practice simply evaluating some logarithmic expressions. So little d. Let's evaluate each, and we'll go through a few of those. First, we'll do number 26. So number 26 says to evaluate log of 1 over 10. Okay, well, what we need to do is we need to write things in the form 10 to a power. So we need to think 1 over 10 is equal to 10 to what power? Well, that's negative 1. Okay, so what we're going to get here is this is going to be log of 10 to the negative 1. So what is the power I raised 10 by to get 10 raised to the negative 1? Well, that's simply negative 1. Easy as that. Okay, what about number 29? Number 29 says log of negative 100. Okay, well, if you want, you can always try plugging this stuff in your calculator, see if you get a nice, neat answer, or you have to think a bit. Okay, well, what did we say the domain for log was? So the domain log of x was, do y'all remember, it's x ever has to be positive. This input needs to be a positive number. Is this a positive number? Well, the answer is no. So in this case, we would say the answer is not defined. Because negative 100 is outside of the domain of the log function. I can't plug a negative number into log. It just doesn't work. All right, little 3. What about, where am I? How about 10? This is number 31. 10 raised to the log of 1. All right, well, there are two ways to do this one. All right, well, first, we can remember that log of 1 is 0. So this is equal to 10 to the 0, and 10 to the 0 is 1. Another way to think about this is we've discussed this. When I say 10 raised to the log base 10 of 1, remember logarithms and exponents undo one another. So when I have the same base here, the base on the exponent is the same as the base of the logarithm, the exponent undoes the logarithm and you're left with the input. So this is simply 1. And we have one of our notes that says that from last time. Okay, well now let's move on to something a little more difficult. The graphs and finding formulas for logarithmic graphs. So let's grab a new piece of paper. And we'll say little e. Find a possible formula for each. All right, first I'm going to start with number 74. And here's the picture that we're given. Okay, well, we're given, and so first you need to understand what this looks like. All right, this isn't a line. It's not a parabola. It's not a power function. This is an exponential equation. It's not logarithmic. This is an exponential, and this is exponential decay, since we're decreasing as we move from left to right. Now, we are given the initial value. The initial value is 0.1. So this is going to have the form y equals 0.1, y equals 0.1 times b raised to the x. All right, well, we're not given any other information to be able to find out b, so we're just going to give a bound on b. Since this is decay, b has to be between 0 and 1. So this is going to be our answer. 0.1 times b to the x, where b is between 0 and 1. All right, how about one a little trickier? 2. How about number 75? Here in 75, we're given a picture like this. All right, now this gets a little trickier. Now first you should recognize that this is an exponential, so we know it has to have the form y equals a times b to the x. All right, now since we're beneath the x-axis here, the initial value has to be negative, and that's negative 1. So y equals negative 1 times b to the x. Okay, now what happens when we have a negative out here? You need to go back a few chapters to remember what does this negative do. It causes us to flip around the x-axis. So what we need to do is think of what would happen if this was y equals 1 to the x. So if this was y equals 1 to the x, it would look like this. It would flip over the x-axis and look like this. We're passing through 1. So what would the b value have to be to have a graph like this? We know the growth factor would have to be bigger than 1. So then when I multiply by a negative out here, it causes this graph to simply flip, and I get something that looks like this. So the b value still needs to be greater than 1. So here the answer is going to be y equals negative b to the x, where b is greater than 1. And to understand this, you need to understand how the transformations occurred a couple chapters ago. So you might need to go back and revisit that a bit. Okay, so now our final example, little 3, is number 73. And we're given this picture. Okay, well, you should recognize this is a logarithm. So this is y equals log of x for the most part. But we're kind of given some more information here. If we look here, is this where I wanted it? Actually, let me put the 3 right. That should be, make this. Let's make a little change. Ignore that. Let's put the 3 right here. We have a point very close to 3, 1. So this is almost the point 3,1. So we need a point on this that's close to this point 3,1. So let's just think, what is log of 3? Well, log of 3, when we plug it in our calculator, is 0.4771. Well, since we want to be almost to 1, what happens if I'll multiply this by 2? So it's 2 times log of 3. Well, that gives me 0.9542. Well, is this number close to 1? And the answer to that's yes. So what we can do is we can think of this as being the equation y equals 2 times log of x. Because if I take my y values and multiply them by 2, I get something that's a little closer to what I have here. All right, so that's what we're going to call that equation. Okay, and thank you for listening, and I will see you guys tomorrow. Work hard and have a good evening.